will continue our exam review, and today we're going to look at some derivatives. So the limit definition of the derivative. First thing we need to do is find f at x plus h. So that means I'm going to take the f at x equation and replace all of the x's with x plus h. So this would become 5 times x plus h squared minus 7 times x plus h plus 1. I'll do my exponents first. This is going to equal 5. If I square that, if I multiply it by itself, I'll get x squared plus 2xh plus h squared. This would give me a minus 7x, a minus 7h plus 1. Multiply the 5 through the brackets, or distribute the 5. We get 5x squared plus 10xh plus 5h squared. And then the minus 7x minus 7h plus 1 follows suit. Now I'm going to fill in the formula. The formula says that f prime x, the derivative, is equal to the limit, as h approaches 0, of f at x plus h. Okay? F at x plus h, that's these 6 terms right here. 5x squared plus 10x h plus 5h squared minus 7x minus 7h plus 1. And then I'm going to subtract f at x. I'm going to subtract these 3 terms here. I'll distribute the negative right now. This would become a minus 5x squared. If I subtract negative 7x, what do I get? A plus 7x. If I subtract a positive 1, distribute the negative, and the sign would become a negative 1. All divided by h. Okay, I'm just filling this formula in right here. So 5x squared plus 10xh plus 5h squared minus 7x minus 7h plus 1. And then I'm subtracting 5x squared minus 7x plus 1. Distribute the negative, you'd get negative 5x squared plus 7x minus 1. All over h. 5x squared minus 5x squared. Negative 7x plus 7x and positive 1 minus 1, they're gone. I'm left with the following limit. The limit as h approaches 0 of 10xh plus 5h squared minus 7h all over h. Now, if you put a 0 in right now, that's what you should do with your limit. Try direct substitution. What's 10x times 0? What's 5 times 0 squared? And what's negative 7 times 0? Right, divided by 0. So I'm going to have 0 plus 0 minus 0 over 0. That's no good. It's an indeterminate limit. How do I get rid of the indeterminate form? I'm going to factor. What can I factor out of the numerator? An h. So take the h out. Open your bracket. Divide the first term by h, 10x. The second term by h, 5h. And the third term by h, negative 7. Close the bracket. Divided by h. Now, what was causing the 0 over 0? This h and this h. So divide them away. That is the factor that's causing it to be indeterminate. And now we can go back to direct substitution. F prime x is going to equal the limit as h approaches 0. It would say 10x plus 5 times 0 minus 7. What's f prime x going to equal? That's right. 10x minus 7. That's my derivative. Because 5 times 0 is just 0. Now, it shouldn't matter how I do the derivative. Whether I use the limit definition of the derivative, or whether I just use a sum and difference rule, basically the power rule with multiple terms, I should get the same answer. And if you flip to the next question, that's what it says. Find the derivative of f of x equals 5x squared minus 7x plus 1. What's the derivative of f of x? What's the notation I would use? What's the derivative of 5x squared? 10x to the first. Excuse me. 2 times 5 is 10. X to the subtract 1 from the original exponent. What happens here? What's the exponent on this x? 1. So I could go 1 times negative 7. Negative 7. X to the 1 minus 1 would be 0. You sure could. What's the derivative of a constant? 0. So instead of showing this line, you could just write 10x minus 7. That is your answer. F prime x equals 10x minus 7. That's that. On to the next rule, the product rule. Okay? Now, when we did the product rule, we did it a little bit different than the textbook. And I suggested that you get like a little eraser so that you can hide these functions. But consider this the first function, which would make this the what? Second. And when we did our product rule, this is what we said. We said the derivative of two functions that are being multiplied together is equal to the derivative of the first function times the second function plus the first function, f of x, times the derivative of the second function. That's how we wrote it. Now the textbook flips it. It doesn't matter when you add it. The reason I did it this way is because this lines up better with the quotient rule. And the quotient rule, the order of the terms does matter. So, let's block out the second. I will write f prime x equals, what would the derivative of this first function be? 3. Okay, I'm not going to write 3x to the 0 plus 0. It's just 3, right? That's the derivative of the first. Now I just multiply it by the second. X squared minus 4x plus 5. I literally write that down. So I'm at this stage of the game. Plus f of x, or the first function. 3x plus 8. You got it. Times the derivative of the second. What's the derivative of x squared? 2x. What's the derivative of negative 4x? Wicket. What's the derivative of 5? A 0. Okay? Now, if I didn't have to simplify, that's where I would leave it. That's the derivative. That is an equation for finding the slope of a tangent line to this specific curve. If I were to simplify, this would become 3x squared minus 12x plus 15 plus, what's this going to give me? 6x squared, and that? Negative 12x, and this? And this. 8 4 is negative 32. 8 times negative 4 is negative 32. So let's group our like terms. So I've got 3x squared and 6x squared, total of 9x squared. Negative 12x minus 24x plus 16x. Negative 8x. Negative 24 plus 16. And then I have 15 minus 32. Negative 17. Is everyone okay with that? After the product rule comes the quotient rule. Okay. Remember when we did quotient rule? We were talking f divided by g, and they were derivative. Get in the habit of verbalizing. It's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator raised to the power of what? 2. Nice. So basically what you're looking at, like, you could think of this as f at x and this as g at x if you want. Or you could use numerator, denominator, or you could use first and second. It doesn't matter. However you're going to remember this. It's helpful to get, once again, get something so you can like focus on the individual pieces, like focus on the numerator or focus on the denominator. We'll start capital F prime x. The prime indicates we're talking derivative. What's the derivative of the numerator? What's the derivative of x to the 1/2? One half x to the, what's a half minus 1? Negative 1/2. That's the derivative of the square root of x right there. Times the denominator, times g at x, minus the numerator, root x. I'm going to leave a little space here. I'm going to multiply that by the derivative of the denominator. What's the derivative of 1? 0. What's the derivative of 2x? 2. So instead of putting a 2 back here, you okay with me throwing the 2 right there? And it's all over the bottom squared. 1 plus 2x to the power of 2. From here, I'm going to clean it up. First thing I'll do is I'll send the negative x to the negative 1/2 to the denominator. F prime x is going to equal 1 over 2x to the 1/2 times 1 plus 2x. Now, I'll do this all in one step. If you multiply the top 1 by the 1 plus 2x, what are you going to get? 1 plus 2x. If you multiply the 2x to the 1/2 by, what's under the 1 plus 2x? A 1. You'll get 2x to the 1/2. So are you okay with me multiplying this out and just calling it 1 plus 2x, writing it as a fraction, over 2x to the 1/2? Minus 2x to the 1/2. I didn't do anything here. Just changed the square root to a 1/2. All over 1 plus 2x squared. Now what we have here is a complex fraction. Do you agree? We have a fraction in the numerator of our larger fraction. So to get rid of that, I should multiply everything by a common denominator. How do you figure out what the common denominator is? Well, you can, one way to do it is just to write down each denominator and multiply them together. So I'll ask you this, what's the denominator in this fraction right here? 2x to the 1/2. What's the denominator under this? A 1. And what's under the 1 plus 2x squared? A 1. What happens if you multiply 2x to the 1/2 times 1 times 1? So there's my common denominator, which means I'm going to multiply this top and the bottom by 2x to the 1/2. Watch when I do this. What would you get if you multiplied 1 plus 2x divided by 2x to the 1/2? If, yeah, the 2x to the 1/2 would cancel, and all you'd be left with is what? 1 plus 2x. Now, nothing's going to cancel here. I'm actually going to multiply that. What's negative 2 times positive 2? Negative 4. What's x to the 1/2 times x to the 1/2? You would add, you write your base down, x, and you would add those exponents. What's a half plus a half? It's 1. It's 2 over 2, right? You add the exponents. A half plus a half is 1 whole. And then on the bottom, I'm just going to write 2x to the 1/2 multiplied by 1 plus 2x squared. Can I multiply that in through the brackets? Yes or no? No, I'd have to square that first. And I don't want to do that. It's just going to make things bigger. So all I do from this point is I group my like terms. What's 2x minus 4x? So you could write that as negative 2x plus 1 or just 1 minus 2x. Your answer, you would probably see the denominator written as 2 root x times 1 plus 2x squared. Can I cancel that 2 with this 2? No, because of that minus sign. That's as simple as it gets. That is the quotient rule. Who remembers what came after the quotient rule? Chain rule. Nice. Chain rule is my favorite. Here's an example of the chain rule. So the first thing I should do is I should rewrite this as 2x squared. Whoa. 2x squared plus 3 to the power of 1/2. Remember, the chain rule works like this. It's when you have a composite function. That's a plus 3. Yes, it is, Hassan. That was my best effort. There's a little lag on my Wacom tablet here. There we go. That's better. Notice the open dot doesn't mean F times G. It's not the product rule. It means F composed with G. And remember this rule. It's F prime G at X, or the derivative of the outer function, multiplied by what? Who remembers? The derivative of the inner function, G prime X. That's what the chain rule looks like. So the first thing I'll do is I'll write capital F prime X is going to equal. I'll bring the 1/2 and I'll multiply it by whatever the constant is there. 1 1/2 times 1 gives me 1/2. Then I rewrite the bracket, 2x squared plus 3. And I subtract 1 from the original exponent. 1/2 minus 1 is like saying 1 over 2 minus 2 over 2. What's it give me? And then I got to multiply by the derivative of what's inside the bracket. So right here, I've got the derivative of the outer function from the 1/2 to the negative 1/2. What do I write here? Not 2x, 4x. The derivative of 2x squared would be 2 times 2, 4, x to the first. The derivative of 3 would be 0. How can I clean that up? What's a half times 4x, or what's 4x divided by 2? Yeah. This and this would give me a 2x here and a 1 here. So I'd have 2x, 1 times 2x is 2x, times 2x squared plus 3 to the negative 1/2. On the bottom, I'm just going to have a 1. Can anyone think of anything else? What don't we like? Negative exponents. So what's the negative 1/2 attached to? The bracket 2x squared plus 3. So what should I do with the 2x squared plus 3? Bring it to the bottom and make the exponent a positive. The 2x would stay in the numerator. Or you could call this 2x over the square root of 2x squared plus 3. One final question. Okay? It's a little application question. And we did these in all of the examples when we did product rule or quotient rule or chain rule or power rule or sum and difference rule. We had equations, or we were asked to find the equation of the tangent line or the equation of the normal line at each part. So first thing I need to do is I need to find y. How could you find y? Yeah, I'm going to fill a 1 in for x into this formula right here. There's the equation for finding y. What's 3 times 1? What's 3 minus 2? What's the square root of 1? What's 4 divided by 1? 4. So when x equals 1, y equals 1. Correction, y equals what? 4. Okay, so I've got x1 and y1. We got to find m, the slope. The slope of the tangent line. How do you find the slope of the tangent line? This all came from what unit? Derivatives. That's right. I got to find the derivative of. That's right. So I'll find dy dx or y prime, whatever you want to call it. So if I start with y equals 4 over the square root of 3x minus 2. Watch me turn this into a chain rule question. Everyone okay with that? How could I make this into a chain rule question? Awesome, Hinchy. Bring the 3x minus 2 to the positive 1/2 from the bottom, from the denominator to the numerator, and it would become a negative 1/2. And now I can find dy dx, or y prime. So think back to the last example we just did. How would I do the derivative of this function? What's negative 1/2 times 4? Rewrite your bracket, 3x minus 2. Subtract 1. Negative 1 over 2 minus 2 over 2. What would this new exponent become? Negative 3 over 2. And what would I multiply that by? The derivative of what's inside the bracket? 3. So when I clean this up, I get dy over dx equal to negative 6. Negative 2 times 3 is negative 6. What will I do with the 3x minus 2 to the negative 3 over 2? Move it to the bottom. That really means the square root of this cube. So if you wanted to write it like this, the square root of 3x minus 2 cubed, that would be fine too. So that's the derivative. What do I use the derivative for? To find m, the slope. Well, in order to find the slope of my tangent line, I am going to take this formula, negative 6 over 3x minus 2 to the power of 3 over 2, and I'm going to fill a what in? That's right. Fill a 1 in for x. So this would become dy over dx equals negative 6 over 3 times 1 minus 2 to the 3 over 2. What's 3 times 1? 3 minus 2. 1. So dy over dx is going to equal negative 6 over 1 to the power of 3 over 2. Well, 1 to the power of anything is what? 1. But like you could think of it as a square root of 1 cubed. Or 1 cubed, take the square root of that. Either way you cut it, you're going to get negative 6. Now that means that m, the slope of my tangent line, is negative 6. I have to do the what? I don't want the slope of the tangent line opposite reciprocal, because the normal line is perpendicular. Whoops. Perpendicular to tangent line. So what's perpendicular to negative 6? Positive 1 over 6. You flip it and change a negative to a positive, or change a positive to a negative. Some people say the negative reciprocal, some people say the opposite reciprocal. Same thing. Who remembers what to do for step 4? How do I find the equation of any line? Y minus y1 equals m onto x minus x1. So what would I fill in for my y1 value? A 4. What will I fill in for my m value? Negative 6 or positive 1/6? 1/6. Wicked. And then it would be x minus 1. Now the textbook usually writes these in general form. I was okay with you writing them in slope-intercept form. To put it in slope-intercept form, we would go y minus 4 equals, this would be 1/6 x minus 1/6. And if I move this over and I add 4, this would become y equals 1 over 6 times x. And then to add 1/6 and 4 over 1, I'd have to get a common denominator. Do you agree that 4 over 1 could be written as 24 over 6? And I end up with y equal to 1/6 x. What would this become? Plus 23 over 6. That is perfectly fine. What's the textbook going to do? The textbook's going to bring everything to one side. Like this. And then they're going to multiply everything by what? To get rid of the fractions. Multiply everything by 6. What's 0 times 6? What's 1 over 6 times 6? So it'd be 1x. Negative y times 6. Negative 6y. 23 over 6 times 6. 23, not 32. I would be fine with either of those answers. Cool?